Okay, welcome to Units 3 and 4, Algebra 2, Semester 1, Final Exam Review. I just want to fly through this with you real fast. Make sure to highlight questions that you might have that you can bring to Starbucks that we can go over. Okay, the very first problem here. Solving the following question. First off, you want to draw your line, circle your creepy dude, and then you ask yourself, okay, how do I go up the PIMDAs and get this guy by himself? The only AddSubtract is inside the parentheses, and that's clear up at the top. So you want to look outside the parentheses. The next thing you would see is that you've got 1/6. How can you get rid of that? Hopefully you realize it's being multiplied right there. So you could divide by 1/6, or you can multiply by the reciprocal 6/1. That'll wipe that out. Times 6, you can put the 1 on the bottom if you want, doesn't matter. So then we'll have x plus 5 squared equals 48. Now to get rid of that square, we need to do a square root. When we do that to the other side, we actually have to go plus or minus radical 48. And the square root cancels the square, so we end up with x plus 5. You can remove the parentheses. There's nothing on the outside of them now. Okay, now we want to get rid of the 5 over there, get the x all by himself. You cannot add what's inside and outside of radicals, so we end up with x equals 5 plus or minus radical 48. Now the 48 can be broken down. 4 will go in there 12 times. The 12's broken down and the 4 is broken down. 2 times 2 times 2 times 2 times 3. So we could get 2 sets of 2's out. We would have 5 plus or minus 2 times 2 radical 3, which is 5 plus or minus 4 radical 3. And let's see, that was a negative 5. I apologize. We subtracted 5 right there, so it's a negative 5 plus or minus. So we get that answer. Make sure to show me that this one has just the numbers in front of the radical incorrect. And this one is really lacking. It has no 5. We could have picked that out right at the beginning, knowing that we're going to subtract 5 on our last step. Okay, next one. Notice it says add. Add is different from later on when we're multiplying. When they have no sign between them, you multiply. But when you have a sign between them, you simply add the like terms. So 11 plus 3 and 1i minus 15i. Put together your like terms. Okay, so 11 and 3 is 14. That would eliminate this one because it has 12. Eliminates this one, it has negative 4. And now a negative 15, a positive 1. They're going to battle. Subtract them, we get a negative 14i. Okay, so that gives us A as our answer. Okay. This one, the only thing that's wrong with it is the 16i. Make sure you show all your work. Make sure you show where the others are incorrect. I want you critically analyzing every answer option. On this one, we need to distribute on our first step. So it is 3i times 6 would be 18i. 3i times negative 5i would be negative 15i squared. Negative 4 times 2 is negative 8. And negative 4 times 3i is negative 12i. So we've got a like term here and a like term there. Let's get them together. The i's generally go in the back. So we'll have negative 15i squared minus 8 minus 12i plus 18i. A negative 12 and a positive 18. You'll subtract those and give the sign of the one farthest from 0. The 18 is farthest from 0. 18 minus 12 is 6i. Right there we can eliminate this one and this one. Now we do still need to continue because we've got the front number to determine. I squared is equal to negative 1. Hopefully in your notes somewhere you've got that radical negative 1 equals I. So radical negative 1 times radical negative 1, or another way to write that is I times I, is equal to, get them out of prison, negative 1, I times I is I squared. Super important concept, super important concept. Okay? So I squared is equal to negative 1. Negative 1 times negative 15 would be a positive 15. Positive 15 minus 8 would be 7. All right? Next item. We need to FOIL or box this. So we have 3 minus 7i times 3 minus 7i. I'm just going to FOIL it. If you box, go ahead and box, you'll get the same answer. 3 times 3 is 9. Negative 7 times positive 3 is negative 21i. Positive 3 times negative 7 is negative 21i. And then our last, 7 times 7, negative times a negative is positive 49i squared. Now, what was I squared equal to? Negative 1. So I can mark through that and switch the sign on the 49 to negative. So we have 9, use commutative property, move these around, minus 49, and negative 21i minus, this should have been a 21, I said 21, I just didn't write it, 21i, 9 minus 49, different signs, so you subtract, find the difference, that would be 40, and the negative is farther from 0, so it's a negative 40. Right there, that marks out this one and this one. Now, we know 21 and 21 will be adding because they're the same sign, so we can come over here and circle that one. Negative 42i seems reasonable for that. It's not 0i, we don't subtract them. Okay? Next one. Since I just did FOIL, I'll do box on this one, just to appease some of you. So we have 4 minus 5i, 4 plus 5i, 4 times 4 is 16, 4 times 5i is 20i, 4 times negative 5i is negative 20i, and negative 5 times positive 5 is negative 25i squared. These two will cancel their opposite signs and equal numeration. So we have 16 minus 25i squared. I squared again is equal to negative 1, so we switch the sign and we get 41 for that answer. Lots of things wrong with these. Here the i's stay. Here, boy, there's not a lot you can say on that one. Just wrong. Okay, next page. Anytime you see an I on the bottom, you can't leave that as the answer. Let me zoom in a little bit closer. Hopefully you're able to zoom in on your end as well. You can't leave an I on in the denominator because that's a radical in the denominator. So you guys got really good at multiplying by conjugates. Conjugate of that would be 2 plus I. 2 plus I. You know on the bottom, it is going to end up eliminating the I. We're going to have our first is 2 times 2 is 4, and our second is negative I times I, be a negative I squared, which is the same as negative 1. Switch the sign, and we get 5 on the bottom. Okay? Now we look at our answers, none of them have a 5 on the bottom, so we need to step forward and make sure that we're doing this correctly. Wait a minute, it just ran out of lead. Nope. Okay, so 5 is on the bottom. Now on the top, we need to FOIL. 6 times 2 is 12. 6 times I is 6I. 2 times 2I is 4I. And 2I times I is positive 2I squared. Now we know I squared is equal to negative 1. Scratch that out. Change the sign. And now we rearrange using commutative property. 12 minus 2 would be 10 over 5. 6I plus 4I is 10I over 5. 5 will go into 10 2 times. 5 will go into 10I 2I times. So that leaves us with this answer. Okay, some of these we just have to work out, others we can spot. Okay, quadratic equation, they want solutions. I look down here and I notice that this is quadratic formula. Negative b, couldn't decide whether to go to a radical party or b squared without 4 awesome chicks, because it all gets over at 2 a.m. Okay, so our next thing to do is to get this in standard form, which is ax squared plus bx plus c equals 0. So we subtract 5x from this side, subtract 7 from this side, get them over here, minus 5x, minus 7. Just subtract them under the like terms. So when we bring this down, it's 3x squared. 7 minus 5 would be a positive 2x. 11 minus 7 would be a positive 4 equals 0. So now our b value will be 3, so we should see negative 3, which we don't. It's probably been reduced. So negative 3 plus or minus b squared, that would be 4, without 4 times, our a is 3. I am so sorry. I was putting a in the beginning as your b value. I'm so sorry. Our b value up here, the negative b, should be negative 2. This might alert us that this might be a correct one. We still need to watch for that and see if it's definitely the answer, not reduced at all, but we're alerted to it being there. So now we have AC times 3 times 4. My apologies. Tired after work. 2a would be 2 times 3. Because there's a 3 on the bottom, we can assume that this has been reduced. So we need to be cautious of that one. Probably not it. Let's go ahead and figure out what this is inside of here. We have 4 times 3 times 4. That would be 16 times 3, or 12 times 4. That's going to be a negative 48. 4 minus 48 would be a negative 44 underneath the radical. And we can bring the rest of the problem down with it, plus or minus the 2 and the 6 on the bottom. We need to get people out of prison. 44 is equal to 2 times 11. And it's got the negative. Remember, when we have a negative under there, we bring it out immediately as I. Then we've got twin 2's, so they come out. write it in front of the I. And then we have 11 left. That is this part of your formula. Put the plus or minus in front of it, the 2 in front of that, and the 6 underneath each. This will reduce to 1/3, and this will reduce to 1/3. That's why we can have 3 on the bottom, because it did reduce. On top, we should have a 1 right there in front. And I made another mistake. That negative came off of my 2. Bring it back in there. Oops. Not that one. So it's a -1/3. That means this one's out because of that 2. That means this one's out because it has no 1. We've got a -1 there and a -1 over here. Hopefully you can see that one. So we need to look at what's the difference between these. The only difference I see is the 2 right there. So let's double check our answer here. We had simplified 44, brought out 2i, and the 11. We reduced the 6 to 3, and we should have marked out that 2 at that time, reducing it as well. And so we'd have just I/3. That would make C correct. This one's incorrect due to the 2. Okay? Become very familiar with your quadratic formula. Next one. Again, they want solutions to the quadratic. Probably the easiest way is the same thing that you did before. Bring them over to this side, so -5y and -9. Set it to 0. So we'd have y squared minus 3y minus 9 equals 0. Now, if you could factor, you could find the solution that way easily too. Since we can't, we look at A, which is 1, B is -3, and C is -9. So a negative boy, that would be a -3. Couldn't decide, radical party, or B squared, -3 squared, without 4A, C, over 2. -3 will be a +3, plus or minus. 9, negative times a negative is positive, that's 36, over 2. So we have 3 over 2. 9 and 36 will become 45. Radical 45 breaks down to 9 times 5, which is 3 times 3. The 3's get out, and we have radical 5 left. That is our answer. Now we look up here, and we try to find this. 3 plus or minus 3 radical 5 divided by 2 would be this one. What's the difference between it and the one above it? Is that the one above it had a negative in the radical. We did not. It was negative times negative is positive. So we're good there. This one, again, had a negative in the radical, so it's out. And on this one, the only difference is it was a -3 out front. Let's double check that. It's always good to double check a discrepancy that way. So it was a -3 that we plugged into the formula that already had a negative out front. So 2 negatives would make a positive. We should be right. Okay, unit 4. It says which equation is represented by the graph? Oh, what's our vertex? Our vertex is 1, 2, 3. Negative 1, 2, 3, 4, 5. This is vertex format. And remember, it's shown as -h plus k, I'm sorry. And when you bring it into the vertex form, it is a positive h, and the k remains as is for the graph. So we're looking for